Step into the virtual world of tomorrow, where artificial intelligence is king and machine learning reigns supreme. As we continue our journey towards the metaverse, training AI for virtual realms has become a top priority. But what does this mean for the future of technology? In this blog post, we'll explore the exciting possibilities that lie ahead as we merge machine learning with immersive digital environments. Get ready to discover how AI will revolutionize gaming, entertainment, and even everyday life in ways you never thought possible. Introduction to machine learning and the metaverse. Machine learning is a field of artificial intelligence that deals with the design and development of algorithms that can learn from and make predictions on data. The metaverse is a term coined by science fiction writer Neal Stephenson in his 1992 novel Snow Crash to describe a virtual reality-based universe where people can interact with each other and computer-generated characters and objects. Machine learning is increasingly being used to create intelligent avatars for the metaverse. These avatars can be used for a variety of purposes, such as providing customer service or serving as digital assistants. In order to create realistic and believable avatars, machine learning algorithms must be able to accurately learn and replicate human behavior. There are a number of different approaches that can be taken when training machine learning algorithms for use in the metaverse. One approach is to use existing data sets that contain information about human behavior. Another approach is to generate new data sets by having humans interact with computer-generated characters in the metaverse itself. Regardless of the approach taken, it is important to consider how the machine learning algorithm will be used in the context of the metaverse. For example, if the goal is to create an avatar that provides customer service, then the algorithm must be able to accurately understand and respond to natural language queries. If the goal is to create an avatar that serves as a digital assistant, then the algorithm must be able to handle tasks such as scheduling appointments and sending email messages. The future of machine learning in challenges faced in training AI algorithms in virtual environments. There are several challenges that must be overcome when training AI algorithms in virtual environments. The first is the issue of data collection. In order to train an AI algorithm, large amounts of data are needed. This data can be difficult to obtain in the real world, so it is often collected from simulations or other virtual environments. However, these virtual environments may not be realistic enough to provide accurate data, which can lead to problems down the line. Another challenge is balancing between exploration and exploitation. When an AI algorithm is first trained, it needs to explore the environment in order to learn as much as possible. However, once it has learned enough, it needs to start exploiting that knowledge in order to maximize its performance. Finding the right balance between exploration and exploitation can be difficult, especially in complex environments. There is the challenge of generalization. Once an AI algorithm has been trained on a specific task, it may not be able to perform as well when applied to a different task or environment. This is because the algorithm has only been optimized for the specific task or environment that it was trained on. Overcoming this challenge will require developing more flexible and generalizable algorithms. Techniques for training AI in the metaverse. There are many different ways to train AI for virtual realms, also known as the metaverse. Some common techniques include 1. Reinforcement learning. This is where the AI is rewarded for taking actions that lead to desired outcomes. 2. Unsupervised learning. This is where the AI learns from data that is not labeled or classified in any way. 3. Semi-supervised learning. This is a mix of the two previous methods, where some of the data is labeled and some isn't. 4. Transfer learning. This is where an AI that has already been trained on one task can be used to help train another AI on a related task. 5. Evolutionary algorithms. This is where AI agents are given the ability to compete against each other in a simulated environment, with the fittest agent surviving and passing on their skills to the next generation. 6. Generative adversarial networks, GANs. This is where two separate AIs compete against each other in order to generate data that is as realistic as possible. 7. Natural language processing, NLP. This is where AI agents are trained to understand and process human language. Benefits of machine learning in the metaverse. The metaverse is a term for the virtual world that exists online, where users can interact with each other and experience a shared environment. It is often compared to the real world, but it is also seen as a separate entity altogether. Machine learning can be used in the metaverse to create realistic and interactive experiences for users. Some benefits of machine learning in the metaverse include: 1. Machine learning can be used to create more realistic avatars that look and act like real people. This can make the metaverse more immersive and believable for users. 2. Machine learning can be used to create NPCs, non-player characters, that are more realistic and believable. This can create richer and more believable environments for users to explore. 3. Machine learning can be used to create dynamic content that changes based on user interaction. This means that the metaverse can constantly evolve and change based on how users interact with it, making it a truly living and breathing environment. 4. Machine learning can be used to create more sophisticated virtual economies, with better item pricing and trade systems that realistically respond to market trends. This can create opportunities for users to make money in the metaverse. Examples of applications of ML in virtual environments. Virtual environments offer a unique opportunity for machine learning, ML, applications. In virtual worlds, data is often more plentiful and varied than in the physical world, making them ideal training grounds for ML algorithms. Furthermore, the ability to reset or pause a virtual environment makes it possible to experiment with different approaches without incurring real-world consequences. Some potential applications of ML in virtual environments include: autonomous vehicles. Virtual worlds can be used to train autonomous vehicles to navigate complex environments and make decisions in unpredictable situations. Fraud detection. By detecting patterns of fraudulent behavior in virtual environments, ML can help organizations protect themselves from financial losses in the real world. Personalized experiences. ML can be used to create personalized experiences for users of virtual reality, VR, and augmented reality, AR, systems. For example, an algorithm could analyze a user's preferences and suggest activities or places to visit within a virtual world. Conclusion. This article has explored the potential of machine learning in virtual realms and the metaverse, a new wave of immersive technologies that will revolutionize how we interact with machines. We have seen how AI can be applied to create realistic avatars, navigate complex virtual environments, and respond intelligently to user requests. Additionally, this technology can help reduce biases which are prevalent in existing virtual worlds such as Second Life. As machine learning advances, so too do the possibilities for more advanced AI applications within these environments. The future is certainly very exciting when it comes to training AI for virtual realms.